All right, well, the plan for today. Due on Tuesday. And exam number 4 is Tuesday. Exam 4 goes on what, 11-1 through 6-4, doesn't it? Oh no, it only goes to 6-3. Huh. Oh yeah. Okay. All right. Well, did everybody get the? Did I pass out the practice exam to y'all, or did I not? I did. Yeah. I did. Okay. Well, if you didn't get it, here it is. It's up here. Feel free to part 1, part 2. We're going to go over it today. There's not class time to work on it. We're going to go over it. Let me finish 6-4. Would that be the best plan? So, yeah, since I'm part way through 6-4, let me finish 6-4, and then we'll dive into the practice exam. I'll just start solving the problems in the practice exam, and then if we have extra time, we'll start 7-1. I'm not sure we will, but we'll see. All right, let's move ahead. So we're graphing. 6.4 is graphing sines and cosines. This section is not on the test. I was thinking it was. It's on the final. 6.3 is the last section that's on the exam Tuesday. So the graphing sines and cosines is not on the test. Not on Tuesday's test. It'll be on the final, which is the following Tuesday, isn't it? Yeah. All right. So how do you do it? How do you graph like a sine or a cosine? Remember the basic. What is the basic sine graph look like? Where does it start? Starts at 0, huh? Goes up, down, and back. That's one cycle, huh? It's one cycle of the basic, unless it's been shifted or flipped or something, more fancy. And what's the basic cosine? One cycle of the basic cosine. Where does cosine start? Starts high, huh? Starts high, goes low, comes back high like a U shape, unless it's been flipped upside down or something like that. Right? We good with that? So you want to just know the basic sine and cosine. One cycle. Sine starts at 0, hits 0 in the middle, comes back to 0 in one cycle. Cosine starts high, goes low, comes back high in one cycle. I mean, they're the same graph. If you they're both just going to do the same thing. It's just they start in different places, right? Sine and cosine are identical, except for they're shifted 90 degrees. That's why the cosine, complementary 90 degree, that's why they name it that. They're the same thing. They're just a little bit of a shift from each other. They just start in different places, right? Okay. So with that in mind, when we look at this question here, y, make it a little bigger, 9/5 sine of negative 2 pi over 5x. First off, what should we do with that negative sign in the parentheses? What can we do with that, with sine? Do you remember? We took it to the front, can't we? Yeah. Now, what if this was cosine? What would I do with the negative in the parentheses? It would what? Disappear. Right, exactly. Let me write that down again. Do you remember that? That'll become important. Let me write it right here. If you have the sine of a negative whatever, theta, call it, some angle, you can pull that negative to the front and it becomes negative sine theta. That's because sine is an odd function. Negatives can come to the front. Whereas if you have cosine of some negative angle, that negative just becomes positive because it doesn't go anywhere. It just vanishes, becomes positive, because cosine is an even function. Remember those differences? It's a lot to remember, huh? So sine is an odd function. Negatives inside come to the front. Cosine's an even function. Negatives inside, you just cross them off. They disappear. So that's the difference between sine and cosine and what they do when there's negatives plugged into them. Okay, so getting back to this one then, this negative right here will come to the front, won't it? So it'll end up being negative 9/5 sine of 2 pi over 5x. We good so far? So that negative comes to the front. Now, what is that negative 9/5 in the front going to do? That's the A, right? Remember, we have the A and the B. So this is A, and this is B. So what is that negative 9/5 in the front going to do to the picture, the graph? What does it mean when you have a negative multiplier in the, multiplying any equation? A negative number multiplying any equation does what to the graph? It flips it vertically, doesn't it? It's a vertical flip. Remember, it's a y effector, not an x. Remember all that back when we first talked about y and x effectors? Anything inside the parentheses in x's little world would be an x effector, but this is not an x's little world. He's in the front, so he's a y effector, and multiplying by a negative flips it upside down. So that's going to mean that this sine graph is upside down because of this negative sign. That negative is going to make it upside down, isn't it? So the sine graph, which normally starts at 0 and goes up first, this one will start at 0 and go down first, won't it? And then, up and back down. It'll be like that instead of like that, won't it? You with me? Mm-hmm. It's going to be an upside down sine graph going down first, then up later, rather than what they normally do, up first, then down. Okay, so with that in mind, we have one more major thing to determine. That's the period, the cycle, the width of one cycle. And what's the formula for period? Period is 2 pi over b, right? 2 pi over b. Have that definitely on your 3x5 card. So the period, the width of one cycle, 2 pi over b. And b is 2 pi over 5, right here. So grab that 2 pi over 5, flip it up, so we get 2 pi times 5 over 2 pi. You with me? 2 pi times 5 over 2 pi. And then put this over 1, cross cancel, it's just 5. So the period is just 5. The width of one cycle is 5. So that means it'll start at 0, end at 5, one cycle. Again, it'll go down first, then up from 0 to 5, because that's the width of one cycle, the period. And how high will it go? How low will it go? Well, that's the 9/5, right? 9/5 minus 9/5, going down first because it's a minus 9/5 in the front. There it is. Which one of those does that? Yeah, it looks like A, doesn't it? A goes down, then up. From there to there is. I know it's confusing because they'll give you more than one cycle, so you want to just hone in on one cycle. There it is. A is doing exactly the right thing. What's wrong with B? B finishes one cycle at 1/5 rather than 5. So B is wrong. What's wrong with C? Same thing, 1/5 or 9/5 or whatever, something. It's not 5. It's supposed to stop at 5. There we go. Is that good? Can you do that on the final exam week after next? Week after next. Final exam. All right. Okay, so they're going to, rather than starting with the equation and doing the picture, giving the amplitude and the period or something, they're going to start with the amplitude and the period, and they want us to give them the equation. So we're working backwards. They say write a sine function. So how do you work backwards? How do you go from information back to the actual equation? Well, just go ahead and write it at first. Y equals a sine bx. Just pop in an A in the front and a B in the parentheses. A in the front, B in the parentheses. Okay, so really our job is to find the a and find the b, and then we have the sine function. So what's the a? Gotta be 2. That's the amplitude, huh? That's just the 2. That's good. Okay. Now we just got to find the b. How are we going to find the b? We got the period, so we could write the period equation, huh? Period is equal to what?
2 pi over 6 pi.
2 pi over b. That's the general formula, right? Period is always equal to 2 pi over b. We use that every time. Use it right back here. Right back here. Period is 2 pi over b. Okay, and they're telling me what the period is. I don't have to guess. The period is 6 pi. So 6 pi is 2 pi over b. Good so far? How do I solve that now for b? Put this over 1, diagonal, right? Bring it up here. 6 pi times b is 1 times 2 pi. To finish getting b alone, divide by 6 pi. B equals, pi's cancel, 2, 6, which reduces to b, 1/3. So I was able to solve for b, and I'm done now. The formula is a, which is 2 sine bx, and b is now known to be 1/3. 2 sine 1/3 x, right there. So that makes sense, how I worked backwards from the amplitude and the period to the equation. Is that good? So I just used the period formula, right? Period is 2 pi over b, period 6 pi, cross multiply, solve for b. Questions? All right. This is very much the way it would be used in the real world. You know, like real life, what do people do with sine and cosine? Remember we talked a little bit? This is a perfect time to say, here's real life. Real life, an engineer or some science person is working on something that goes up and down, up and down. That could be all kinds of things. The power that comes right out of the wall that's plugged in right there to that alternating current. Alternating means up and down, up and down. The power that comes out of the 120 volts in the wall there, 120 amperes. And that's one thing. Could be the tides in the ocean, right? The tide rises and falls, rises and falls. Could be the motion of a carousel, up and down, up and down. There's all kinds of things in real life. They go up and down, up and down. In real life, an engineer would look at something going up and down, and they wouldn't automatically start with the equation, right? The thing coming out of the wall doesn't say my equation is the sine of 3x, but it doesn't. It just goes up and down, right? So you look at something going up and down in the real world, and you say, okay, there's the real life thing. How do I turn that into an equation so I can use the equation to answer and solve all kinds of other things about what it's going to do in the future and how to amp up the power and on you go. I want to make an equation. Remember, math is made up to fit what we see in the real world, huh? So here's a perfect case in point. You would see something going up and down like that in the real world, put it on a graph, and then think, okay, how do I make an equation that goes with that? How do I put words to that song? How do I put an equation to that picture? All right, so let's do it. So the first question is that a sine graph or a cosine graph? Because they're giving us both choices down here. Is that a sine or a cosine graph? How do you know whether it's sine or cosine? What tells you that? Where it starts, huh? Yeah, this one starts at 0. This one starts at 0, right? Right on. Notice, and when we say 0, we mean the midline. So careful. If the graph has been moved up or down, giving you a hint, the next one's going to be really tricky, and they're going to move it. And it's going to be hard to tell where the real starting point is. So put this idea firmly in your mind. When we say sine starts at 0, if this sine graph was moved way up here, like the whole graph was up here like this, shifted, then this would be his starting point on the new midline, right? So when we say it starts at 0, we mean it starts at its midline. I keep calling it midline, why? Because that line goes through the middle of the graph. So if it was moved way up here, you'd have to draw a line through the middle first. And then that would be like your new origin. Right? Okay, we'll see that in the next problem. So, okay. So, yeah, so this one starts at 0. Here's one cycle. You might just hone in on one cycle. Forget about everything else. Just there's one cycle. Very good. And, whoops, don't scribble all over your graph. So starting here, ending there, there's one cycle. So it's a sine graph is correct. Y equals A sine BX. They put a W. It's actually an omega. It's a Greek letter. Whatever. Call it whatever you want to call it. I'm just going to go A sine BX. So I just got to find the A and the B now. What is the A? Let's start with the A. What's the amplitude? What's the A? 6? Is that right? Almost. It's got to be -6, doesn't it? Because it's going down first. Everybody see it's going down first? Right? Because the normal sign goes up first. This one's going down first. So it's got to be negative. Like that. Okay, good. And now we got to find the B. Can you find the B? What's the period? Can you tell the period of that one?
Is that 3?
Yeah, that's got to be 3, huh? 1, 2, 3, 4. So that's got to be 3. Very good. So the period is 3, isn't it? Remember, the period is the width of one cycle. Width of one cycle. So it goes from 0 to 3. The period is 3. The period is the width, it goes from 0 to 3. The period is the width of just one cycle. Does that make sense? You always want to hone in on just, because they always give you more than one cycle, so you want to hone in on just one cycle. So just, starting at 0, down, up, back to 0, or back to the midline. It's really the better way to say it. That's one cycle, isn't it? So the period means the width of just one cycle. So the period's 3, so you know what to do from there, right? So we say period is 2 pi over b, and then put this over 1, diagonal, diagonal. 3 times b is 1 times 2 pi. So bring that over here. 3b is 2 pi, divide by 3. b is 2 pi over 3. b is 2 pi over 3. So our equation is -6 sine 2 pi over 3x. There we go. We found the equation. So we were able to go from a picture back to an equation that produces that picture. That's how math works in the real world. You see something real, and you make up a formula in math that would fit that reality. The graph of this would be exactly that. That's it. Does that make sense, how that works? So we would use anything that goes up and down consistently in the real world, we can make up a sine or cosine equation to fit that reality, and then we can do all kinds of things with it that are convenient for us to solve. All right, we good? I'm going to go to the hard one. You got the easy one? It's going to be a challenging one. It's a big joke. You can answer this one without even finding the period. Give it a try.
You were right.
Yeah. I'll give you just a second. You don't need to do much on this one. All right, so first off, look at where it starts. It starts right up here, right? So is it sine or cosine? Which one is it? It's got to be cosine, huh? Because sine starts at its midline, or 0, but this is not. This is starting at its peak. Cosine starts at its peak for positive cosine, or starts at its bottom for negative cosine, where sine starts in the middle, doesn't it? It starts at 0. So anyway, yeah, this is a cosine graph, and it's a positive cosine graph because it's starting high, so it's positive cosine. There's only one of those that's positive cosine, right? Positive 6/7 cosine, I should say. right? Because the 6/7 is the amplitude, so it's got to be that one. I didn't even bother to find what the period is. I didn't need to. They made the multiple choice so easy. It's got to be that one. It's the only one that's positive 6/7 cosine. Now, just for fun, we can find the period. Let's say bx. Okay, so period. What is the period? Let's just verify it's true. What's the period? Because you will have to, and some other ones. There'll be more tricky ones. So how could we find, let me give you a second. Could you find the period there? So what's the period? Remember, what's one cycle of cosine? Goes down and back up. Isn't that one cycle? Right? One cycle of cosine's a U shape. So that means a half, huh? So the period's a half. So then we go, okay, period, you know the formula. Well, let's put it right here. 2 pi over b. Period's 2 pi over b. And then go diagonal, diagonal. So 1 times b is 2 times 2 pi. So b is 4 pi. Sure enough, that's why they have the 4 pi x. Because b is 4 pi. Good on that? All making sense? So you really want to know what is one cycle. So for cosine, the U shape is one cycle, or it might be an upside down U if the cosine's been flipped upside down. And for sine, one cycle starts in the middle, goes high, goes low, back to middle, huh? So make sure you're really clear on what one cycle is for sine and one cycle is for cosine. That's how you find the period. All right, you ready for the hard one? If you can get this one's a little tricky. Okay, try that one. All right. Want me to jump in and help? You know what? This one's been moved up, hasn't it? It's been shifted upwards. So that's tricky. You got to have the midline. Let me go back and show you what I mean. See how we always need the line going through the middle of the sine or the cosine, either one, same thing. You've got to have that line going through the middle of the graph. You need to see that. That's your baseline by which everything else is compared. So we really have to put the line through the middle. Where is it? It's about right here. Put that line through. That's tells you the shift. The middle is normally, the x-axis, but it's been shifted up, hasn't it? The middle has been moved up. How high is that middle? Can you see this is 4, this is 2, so it must be 1. So everybody see that? That's at a height of 1. 1 right here. So it's at a height of 1. So the middle is a height of 1. Okay. So therefore, looking at that, so forget about the x-axis. Don't let that distract you. Just this line right here is the important line. That's the midline. So tell me then, with that midline, where does this graph start? Well, it starts right here. Again, don't look at that and go, it starts at 0. Remember that. Forget about the x-axis because that's not the midline on this one. Where does this graph start? Does it start in the middle of its midline? No, it starts low. So this is what kind of graph? Negative cosine. Does everybody see that? Because it's not starting on its midline, right? You guys with me? Cosine always starts out high or low, above or below its midline. That's what cosine does. That'd be a negative cosine. Whereas sine starts out on its midline, right? On its midline, doesn't it? That's the difference. Sine starts in its middle and comes back to the middle in the end. Sine starts low, below the middle if it's a negative cosine, or above the middle if it's a positive cosine. So this is a negative cosine when we realize what the new midline is. It's been shifted upwards. So this is a negative cosine graph, and it's got a 1 added at the end. Added, not subtracted, because the graph has been moved up. Remember, y effectors or at the back, and they move the thing up or down. So it's one of these two. We got to find the period to find which one. It's not this because that's a sine. It's not this because this has -1. No, no, no. It's +1. The midline has been moved up 1, right? Not down 1. Good? So it's one of these two. Now how do we find which one? We got to find the period. So can you do that? Have you done that already? How do we find the period? One cycle. So where does it end one cycle? Right here, 1/3, huh? Because remember, this is upside down u. That's one cycle. Right? The cosine is a u, up or down. So the period is 1/3, which is what? 2 pi over b, isn't it? So the period's 1/3, which is 2 pi over b, diagonal, diagonal. 1 times b, 3 times 2 pi, b is 6 pi. So then it's negative a cosine bx. It's negative, what's the a? What's the amplitude? Yeah, what is the amplitude on this one?
1.
It's just 1. So everybody said amplitude is how far above and below the midline you go. This one only goes 1 above and 1 below the midline. Up to 2, down to 0, huh? The midline's 1. It goes 1 above that and 1 below that. 1 above its midline, 1 below its midline. That's amplitude. So the amplitude is just 1. Cosine in the b is 6 pi x. There it is. That's as hard as they're going to get, I promise. No harder than that. Turning a graph into an equation. Is that good? Feel like you could do that on the final and week after next? You getting ready to wrap this class up? It's all over. Week and a half. All right. I think this one's super easy. Yeah. Try that one.
Got the answer.
Yeah, this is a super easy one. Where does it start? Starts right here. Whoops. Starts right there. Ends right here. There's one cycle. Starts at -7. It's a -7. Is it sine or cosine?
It's cosine.
Cosine. It's not starting in the midline, is it? -7 cosine. There's the only -7 cosine. I don't even need to find the period. There's only one -7 cosine. It's that one. Easy. Move on. In fact, let's just stop there. Number 20 is just the same kind of